All right, so we are now going to use the graph that we created up above, and we're going to go through and talk about some vocab terms that are associated with graph theory. So I already talked about what vertices are, but we never actually listed them out. So now what I'm going to do is I'm going to list all of the vertices that we had in the graph up above. All right, so we are listing those vertices out. So we're going to put them in what is called set notation. So we're going to use two braces. And then we're just going to list those capital letters. So capital A, and then we're going to separate the vertices using commas. So there were four vertices above. So I have four letters in my list of vertices for that graph. Next, we're going to do something very similar for those edges. There were seven bridges, so there were seven edges. But now what we're going to do is we're going to list those by using the endpoints of those edges. So what is that? Which vertices are those edges connecting? All right, so this is how we're going to do that. Since there were seven bridges, there are 1, 2, 3, 4, 5, 6, 7 lists of edges in my list. Once again, I'm using set notation, so I'm using the braces. And then I just put the two vertices together that are the endpoints that the edge is connecting. So AB. And then once again, I have AB. So I actually have it listed twice. I need it there because I need it to be known that there are two unique edges connecting A to B. If you wanted to put BA and AB, that's fine. It doesn't matter which vertex you list first. What's important here is the fact that A and B together, okay, there's an edge connecting them. Not just once, but twice. Same thing with BC. Sorry for my handwriting, but it appears twice because there were two bridges connecting B to C. And then AD, BD, and CD. So sometimes you are going to be given a list that looks like this, okay? A list of vertices and a list of edges, and you should be able to draw a graph based on just what the list says. Okay, a connected graph is a graph where you can go from one vertex to the next without lifting up your pencil. So here's an example, another example. The one up above worked as well. But here's another example of a connected graph because there are two vertices and there's an edge to go back and forth between the two. But if I put another vertex right over here, now I've created a disconnected graph because I have this vertex where I can't connect it over here. The degree of each vertex, or sometimes called the valence, is just how many edges do you have that's leading into that vertex. So if I look at vertex A, I have 1, 2, 3 edges that go to vertex A. So this one, A, the degree would be equal to 3. For B, if I count how many edges there are coming into it, we have 1, 2, 3, 4, 5. So degree B would have a vertex B would have a degree of 5. C has 1, 2, 3 coming into it, so the degree of C is 3. And D also 1, 2, 3. The degree of it is 3. Adjacent, two vertices are adjacent if they are connected by an edge. That's just your basic definition of adjacent. Two rooms are adjacent to each other if they have a shared wall. So vertices are adjacent if they are connected by an edge. So the only vertices I see on here that are non-adjacent would be A and C because there is no bridge going directly from A to C. However, A to B, those are adjacent. B to C, those are adjacent. B to D, those are adjacent, and so on. So then we can create what's called an adjacency matrix, which could be given to you as well, and only that could be given to you, and then you could be able to draw a graph based on the adjacency matrix. So now I'm going to make the adjacency matrix for our graph. Okay, so here's what that adjacency matrix looks like. Each of the rows and each of the columns are just the vertices in the graph. And then what you do, so it's just read like a table where A meets up with A. This is saying that there's an edge connecting A back to itself, which there isn't. So I put a dash here. You could put a 0 as well. If you did have one of those, that's going to be our next vocab term. That's going to be what's called a loop. Okay, but there is an edge going from A to B. In fact, there are two of them. From A to C, there isn't one. From A to D, there's one. So that's how you read this. Okay, and then there's something else that is good to note about an adjacency matrix in the fact if you were to sum the rows or sum the columns, which will give you the same thing, you should see something. So 2 plus 1 gives me 3, 2, 2, 1 gives me 5, 3, and 3. This just gives me the degree of each vertex.